My name is Rachel. I will own my bias from the outset. I am a kinesthete. As with many things in life, you can blame this on your parents. My parents founded a Montessori school in a tiny town in West Texas. If you're familiar with Montessori education, you know that the edict is, I hear and I forget. I see and I remember. I do and I understand. And so I'm very much a three-dimensional thinker, an embodied learner, and I took that preference for kinesthetic learning with me into a career in dance, almost into a career in medicine due to my fascination with the mind and the body. And throughout my life, I was always incredibly frustrated with the brain-body binary. I found it did not replicate my experience, which was one of very solid enmeshment there, and much success because I was able to draw upon both domains. And I noticed that we could be more effective if we were able to leverage our full mental capacity and our full kinesthetic capacity all at once. So I'm very interested in spatial computing, MR, XR, VR, because I think that these tools are uniquely suited to help us confront the challenges of our time. So what do I mean by that? We live in an age of information. We all know it because we are inundated with information every day. Our interfaces, our environments have evolved over time from the savanna of our nomadic ancestors to the store of our grandparents' daily experience to our desktop UIs. New interaction has caused us to have an increased cognitive load as we've had to learn those new interaction paradigms, which leads to a burden on our attention. This wealth of information results in a poverty of attention. Herbert Simon, who is an American, well, he passed away, an American Nobel Prize-winning economist, sociologist, psychologist, spoke of this very eloquently. The full quote is tweeted on my Twitter account. You should check it out because it's beautiful. But essentially he says, in an age where we have so much information at our fingertips, that information will consume a resource. That resource is our attention. We have to learn to leverage it wisely. And so I would ask every one of you, on a personal level, to consider your attention as one of your most important, scarce, valuable, critical resources. And then I would ask all of us to consider, how do we want to leverage information systems? How do we model, interact with, and process information in meaningful ways? This is a critical concern of our time, and my friends in big data know this. It has massive impact, not just on the quality and quantity, but also the type of outcomes that we create and the kind of world that we build. So the way that we model an experiment changes the outcomes of our experiments. We all know this if you have a background in science. And I'm curious how these tools will impact the way that we do that. I think that VR and AR are useful in part because they bring computation out of its little boxes and into our bodies. So, cognitive ecology. Knowledge exists as a mind-body-world system. Theories of cognition tell us what dancers have always known, which is that thought is physicalized. That is essentially the definition of embodied cognition. We use our bodies and our physical aspects of our environment to offload storage and to simplify cognition. So if anyone in this room has ever crossed their fingers to remember something, that is an example of embodied cognition. We have moved forward in understanding cognition, and we now discuss inactive cognition, which is that our thoughts are actually shaped by our interactions. One example of this is indicated in every one of our lives by the process of aging. So for example, real-world biomechanical constraints on our physical bodies actually constrain our mental capacities. So for example, your episodic memory, as your physical experience becomes more constrained, will also become more constrained. That means your experiences, your memories of your own life are harder to retain the less you can move around the world. And this is really fascinating. Many people have started using virtual reality as a way to enhance episodic memory in the elderly. There's a study from Italy published in 2016 of elderly people navigating a room passively through computer-generated tour versus actively, exploring by intent. And those who actively navigated the room had increased object recognition and increased retention of all of their experiences. So a number of other studies are now in the works to explore how virtual reality can actually help all of us retain our memories. It's also true that the ability to physicalize our experience aids in memory formation, not just retention of information. So another study of medical students released by Columbia University demonstrated that students who were able to manipulate an internal anatomical structure learned much faster than those who could view the manipulation happening in VR. So those who could actually touch it learned much more quickly, especially those who had slightly lower spatial thinking skills. And this is something, again, that dancers have known for decades. We call it marking. We abstract our ideas in the body. We move through choreography by moving our body around without having to enact the entire piece as a way to physicalize and retain information more effectively. Now science is catching up with that, and virtual and augmented reality have a role to play in this. So these studies make me curious. If we can effectively simulate presence and create interaction, we suddenly have a powerful tool for attention and information management. But in order to make this possible, we first have to design meaningful virtual experiences. There are many components to what it means to design an immersive world. I will talk about 3 today: novel software and hardware, narrative paradigms briefly, and natural interaction. So let's start with software and hardware. I work for Leap Motion, which is a company that is focused specifically on the problem of embodiment and interaction in the digital world. Why? A couple of reasons. We all know that the magic of VR is in presence. It is that sense of body transfer that creates immersion, empathy, learning, healing if you're using it in therapy. And now that we've talked about embodied cognition, you have a bit more background in why that is. Mirror therapy has revealed this to us for decades. Veterans who came back from war, missing a limb, having phantom pain, would experience mirror therapy to unclench their non-existent arm. So we know about this. We've been studying this for many, many years. We have information that we can leverage. Another important value add, in addition to the magic of presence, is resolving a bottleneck. This is back to my annoyance with the brain-body binary, separating these things out as if they don't interact, as if they're not the same thing. We currently use linear binary input mechanisms to interact with knowledge systems, whether that's the punch card or the keyboard or the mouse. Click, 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 punch, punch, punch. This is the way that we access almost all of our information today. Why aren't all of you as annoyed as I am by that? I hate that. You see it coming up whenever you think spatially. For example, are there any designers in this room? Any designers? Okay, a few. So traditional designers will model a 3-dimensional shape using a computer program. You'll pinch, you'll push, you'll grab, and it'll take you an hour to model a mug. Give a 5-year-old a hunk of clay and they will do it in 5 minutes. That's the bottleneck I'm talking about. So how do we do that? With Leap Motion technology, which is what you're seeing here, this is a mobile device, we essentially have 2 infrared sensors mounted and 2 infrared LEDs that shine 860 nanometer light onto both of your hands. Then our tracking software interprets what those sensors see, extracts the position of 26 joints on each arm, sends that data through our API, renders it in the digital world, and now the user is present. The user has their own hands to interact with a spatial digital world. This creates body transfer. So what do we do then? We have to know, what is the user's mask? This is the second piece I would ask you to consider as you are looking at content. Are they a voyeur? Are they a free agent? Are they a guest? These options burst open traditional concepts of narrative design. We're used to linear, time-based narratives where the narrator maintains control. Virtual reality, as we all know, creates the opportunity for non-linear, often emergent narratives, spatial narratives that are based on feedback loops, not a linear trajectory. Based on feedback loops, that's how we learn. That's how your children learn. So you have choices. How much impact would you like your user to have in the story? Should they have a lot of presence or less presence? You have to make trade-offs with these choices. As presence and impact increase, the narrative becomes less linear and more emergent. That means people will drop into the space, have this deep sense of presence, and get super distracted by like the texture of the ground or the caterpillar on the leaf, and the narrative's going on and they've lost the first 2 minutes of it. So be conscious of the mask that you are creating for your user. On the other hand, if you want someone to really follow a linear narrative, maybe they will have slightly less sense of presence, but they'll be hooked into that narrative. They'll stay with you. So these are just choices that we have to learn to make in virtual reality when we're designing. So tactically, how do we enact that? One important aspect of it is to make a decision about your user's perspective with respect to position and visual scope. So these define your user's mask and the narrative significance of everything they see. When you've made these choices, your user is present, they have a defined narrative perspective. How do they interact? This is an often misunderstood and undervalued aspect of how to design an immersive story world. At Leap Motion, we focus on interaction design, and innovating there is in our DNA. It's hard because users' tolerance for an unrealistic physical interaction is so low because they have their lived experience to compare it against. It's very hard. So, for example, we have the interaction engine, first released in July 2016. We set the rules for the digital universe. This matters because you can have the world's most perfect hand tracking. You can have an SDK that renders hands in VR digitally, but if you can't interact with digital objects in a physical way, everything is useless. So digital objects don't have mass, they don't have force. You have to code that. So that's the innovation that we have had to do to create the interaction engine. And it accounts for standard physical interactions, smacking objects, and transferring the right amount of velocity, grasping an object reliably in a way that feels right. Non-physical interactions, things that wouldn't happen in the physical world, but that you have to account for in virtual space. So for example, passing your hand through an object or pushing a block that's sitting on a table through the table. Or abstract interactions. For example, opening up your hand and seeing a virtual wearable user interface. So we have a new update coming to this on Tuesday, and that's very exciting. We're going to release that to our developer community. It has new user interfaces, and it makes it a lot easier to use. Basically, you can drag and drop digital objects in Unity, click a box that says use our interaction tools, and it's there. So if you are interested in that, even if you don't develop with Leap Motion, you can still utilize this tool. I would definitely suggest checking it out. But where do we put this tool to use? 4 categories I often discuss are the dangerous, the expensive, the counterproductive, and the impossible. These are things that virtual reality is uniquely suited to. Boxers and football players being trained before a big game or event without getting bruised and concussed. Expensive things, training astronauts or doctors. Counterproductive things, cutting down an entire forest in virtual world in order to teach people about ecology. Impossible things, changing your physical body, putting a tall white man into a small black woman's body. What does that feel like? Or telepresence, which is such an interesting use case to me because it has very strong financial, ecological, and social impact. I hope some of you in this room are working on that. But I'm going to give you some concrete industry use cases as well. Education, as we discussed previously, is ripe for use with virtual reality. There are new ways of learning through gamification, immersion, empathy building. This pictured game was funded by the National Science Foundation. It lets students grab, pull, and push tectonic plates and resulted in a 30% learning increase. The EU, for example, is funding changing attitudes about domestic violence by creating virtual experiences. Healthcare, there are ways to, you'll see a nice GIF here, so you can see the hands don't have a glove, they don't have anything on them, it's just this person's hands. You can model a cadaver in VR, and instead of having to source a new cadaver for every medical student who needs to dissect a cadaver, suddenly you have scaled education and learning and decreased costs substantially. You can allow patients to understand 3-dimensionally their own structures in their body, or medical students. Industry as well can benefit from these types of examples, navigating a plane cockpit as featured here. Data visualization is a huge opportunity, allowing you to sort, map, and tweak variables physically. One example of this is, I want you guys to think about Newtonian physics. We all kind of understand gravity. You know that if you throw a ball, it goes in a parabola. How about quantum physics? I bet very few of you have some intuitive understanding of quantum physics. Why? Because we don't have a physical experience of it. But imagine if we could code those physics and put them in a virtual world and allow every student, K through 12, to have a physical experience of quantum mechanics. That would be a totally different class of educated people. Imagine the insights we would create about the world if that were possible. So this is one of my favorite thinkers, Buckminster Fuller. If you want to teach people a new way of thinking, don't bother trying to teach them. Instead, give them a tool, the use of which will lead to new ways of thinking. XR is a tool for transformation, and it will form us as much as we form it. The objects, the systems, the environments that we design have profound impacts on our cognitive capacities. And the way that we model the world changes the way that we think about it, the kinds of solutions that we come up with. And I'm going to give you an example. Think of it as a self-portrait. Here we are. So this is Earthrise, taken in 1968 by Apollo 8 astronauts. Here is a view of the world. Here's another view of the world, of us, that you guys have probably seen in school. This is the year 2000, created by the American Museum of Natural History, the solar system. Here's another model of the world, created in 1975, describing how reality is spiral orbital, that all terrestrial critical path developments inherently orbit the sun, no path can be linear, all paths are precessionally modulated by remotely operative forces producing spiralinear paths. Everyone understands what I'm saying, right? Made so much sense. Let me show you what I mean. This is where you live. This is your world. So what I want us to consider today is that XR, VR, MR, AR is more than glorified film. It's bigger than gaming. It upends narrative control. It unleashes mosaic perspectives. It demands embodiment. And it encourages us to think in new ways. As a friend of mine at Baobab Studios likes to say, VR has the empathy of films, the agency of games, and the motivation of life. It's an exponential technology, which by its nature will democratize and disrupt. And we will underestimate it in the short term, or in the long term, and overestimate it in the long term. Wait, overestimate in the short term, underestimate in the long term. There we go. So how do we get there? If we want to really do this, if we want to change the way we think about the world, this depends on a collective imagination, an extraordinary collective imagination. We have to embrace the gray area between pragmatism and imagination. And we have to push the edges of this tool, because it's not going to do anything if we don't make it happen. So my question to all of you is, what kind of reality do you want to create? How do you want your children to learn? How do you want people to think about where they exist in the world? Because that's the stuff that you can play with now. How do you want to rewire people's minds? And if we do that consciously, we can transform not only how human beings interact with technology, but also how human beings fundamentally understand the world. Thank you.